Okay, so looks like we're going to talk about geometry,
And classification of
classification of shapes. So that means this is some kind of graph theoretic representation. Okay.
And we had talked a little bit about classification of shapes.
Right.
And
Let's do that.
If you remember what that was polygon has triangle, quadrilateral,
Yeah.
pentagon, and so on.
So when you say triangle, you mean the number of shapes
sides
has
is-
this value,
Yeah.
triangle, number of shapes,
Has
sides has this
this
value,
value.
4
Yeah,
and so on.
4.
So that's what it means to say quadrilateral.
quadrilateral.
Yeah.
Yeah. So we had created one classification where, if you remember, in quadrilateral, we had decided that we have rectangle,
Yes.
meaning above that we would have had a parallelogram also.
Parallelogram and so
But
on.
let's just
Yeah.
stick with this for now. There was parallelogram somewhere there.
Well, why don't we, to make it easier for people, why don't we just
Yeah, we
do
can
that?
just do it.
Yeah.
Okay.
For if it is a quadrilateral, another option is parallelogram. Yeah. That makes it easier.
Yeah.
And if it is a parallelogram, then there is
Rectangle.
rectangle. And if it is a rectangle, then we can have a square.
So notice one other way we could have gone about
Mm.
this. We could also have done parallelogram rhombus.
Right. Yeah.
And that to square.
Yes.
So these are two possibilities straight away we see over here.
Yeah.
And both of these probably have some interesting theorems associated with them.
So rhombus means all the sides are equal.
All the sides are equal, but
But the
angles,
angles
there
are
could
not
be
equal,
something
yeah.
like this,
Right.
like a diamond shape. Thing.
Yeah. But isn't this a parallelogram?
It's a parallelogram as well.
Okay.
So it's a
two kinds of
So
ways of-
parallelogram with opposite sides equal,
Yeah.
like a rectangle, like a square is a rectangle with opposite sides equal.
Right.
So this is an alternate, which is probably a useful
Yeah.
alternate
Yeah.
classification.
Yeah. Okay.
So here what we've done is presented various alternate classifications of polygons, not
Yeah.
at this level, not down here, but up at the level of polygon.
Hmm.
So
So you have equality of angles, equiangular.
yeah,
Equiangular, then a square and rectangular equiangular. So
Equiangular.
there will be something.
So here you would have equal, and then you would maybe have some relationship between equal, equilateral, equiangular polygons
Hmm.
with 4 sides are rectangles.
Right.
Yeah.
And then there is
And there's
equilateral.
Equilateral,
Right.
where you can say something like equilateral polygons of with 3 sides
Mhm.
are also equiangular. So basically, what you're saying, there's a triangle which has equal sides, also has equal angles.
Right. So that seems to be a theorem here.
Theorem here, but using these
Yes.
two or classifications of polygons.
Yeah. So essentially what this is saying, what this is doing really giving you the space of possibilities.
Yeah.
But then not all possibilities are adjusted, some are. So it is not possible for a triangle to be equiangular and not equilateral. Right?
Yeah. Yeah.
So
yeah.
you can have a right angle triangle here.
Yeah.
You can have a right angle, rectangle and square, all right angles.
Yeah.
But you cannot have a pentagon with all right angles or a hexagon.
Yeah, but even a triangle, you can only have
Cannot,
one
yeah,
right angle.
Right.
Yeah.
You can't have a.
So we can actually define another parameter, right angledness.
Right.
So,
Yeah.
so in the sense of all the so if we define right angleness as all angles have to be equal, our only possibility, all angles have to be right angles. Our
Yeah.
only possibility is rectangle, so that's not a useful classification.
Yeah. But here only one.
Here only one angle is right angle.
Here you could possibly have.
So if you define right angleness as the maximum number of possible right angles in a shape.
Right.
So this is a right angle triangle.
Mm-hmm.
Any rectangle is a right angle
Yeah, that's right,
right
yeah.
angle quadrilateral.
If it's a pentagon,
If
only
it's a
3.
pentagon, yeah,
Yeah,
you could only
3.
have 3.
Yeah.
If it's a
Hexagon.
you could have
Again 3 only, right?
See, that's interesting.
Oh, if it is convex, I guess we have to introduce that notion.
Yeah.
Right? If you allow it.
Yeah.
No, even without that, you could do this, right?
Yeah.
So if you create a structure like this, and then if you do this, then you get a pentagon. But if you do this,
yeah,
you get, and then you can do this. No.
Yeah.
You can keep increasing number of sides, keeping this. Oh, only 2 here.
Yeah. So
Yeah.
So whatever. So right angleness is the property of these
Yeah.
sorts of shapes, where you have the maximal number of right angles
Yeah.
for a given shape.
So it looks like, except for these 2, this has maximum is 1. This one has maximum is all of them.
Ah.
The rest are all maximum is 2.
No, you could be able to do that. So
Right. Okay. So you could have. That's right.
Yeah.
Maximum 3.
and then you could go on like this.
You can't have more than that, right? Yeah. Unless.
No.
Oh, notice what you have done here is this. Now you have a concave.
Yeah.
Suppose I insist that everything is convex.
Yeah. So now we come to convexity.
Yes.
Which is also an interesting parameter
Hmm.
because there's not all that much interesting about non-convex shapes.
Yeah.
So if you notice, all triangles are convex because you can't
Yes.
draw a concave triangle.
Yeah.
Try doing it.
Yeah.
If, for quadrilateral, only something like this would be.
Right. But a parallelogram cannot be.
Parallelogram
Cannot
cannot
be. Yeah.
convex.
And that means a rectangle and square cannot be convex.
Yeah, yeah.
And
So it seems like all the interesting properties about polygons are about convex polygons.
right.
And which is why here we've only put one arrow to convexity, for convexity to convex and not to non-convex.
So that means non-convex is not a category.
Non-convex is not an interesting
Yeah.
classification.
There are no theorems on it.
There are no theorems on it.
Yeah.
If there are, we don't know of it.
Then there are no theorems. This is a convex.
Yeah.
So if you have, sorry, this is a concave.
Nah.
So if you don't want concavity,
Yeah.
then the maximum number of right angles in a pentagon and upwards
Yeah.
will be only 2.
Yeah.
That's an interesting theorem.
That's very
Yeah,
interesting.
the relation between right angleness and convexity. So we're looking for a space in which,
There are theorems.
yeah,
And it'll be intersections of these spaces. There are
Yeah.
spaces which are created here. So, three-sided, equilateral, equiangular would be an interesting thing to study.
Yeah.
And that would be something with basically
Yeah.
this. And you don't need to repeat. You don't need to say equilateral and equiangular because
one means the other.
One means the other in the case
Yeah.
of triangle.
But a regular polygon would be both.
Yeah,
Equilateral and equiangular would be a regular
a
polygon.
regular polygon.
You can combine them. Yeah.
Yeah, yeah.
Okay.
So the goal of this is just to show various alternate classifications of shapes and show that there's interesting things to say about each of these. And so that's why when we had given that one classification, that was just one classification. I'm sure you've seen the rhombus classification.
Right.
I'm sure you've seen the equality of classification. I'm sure you've even seen regular as a separate category,
Yeah.
which includes both of these, which is the union
So
of.
it looks like that these things are actually different dimensions,
Yeah.
and you have different traits, different variables there.
Yeah.
And what you have given here is the space of possibilities.
Space of possible traits, and
Yeah.
then these would be the values of those traits.
Right. And
Which-
then you have theorems that reduce the class of theorems such as equiangular triangle is equilateral and vice versa.
Yeah.
Reduces the class of possible.
Yeah, trait.
Okay.
So there'll be class of traits, and then there'll be class of possible traits because
Possible shapes.
possible shapes.
So the theorems then are stating certain laws on the combinations of traits.
Yeah. So, for example, you can't have equilateral right-angle triangles.
So that combination is impossible.
That combination is impossible.
Right.
So
you cannot have a pentagon with 5 right angles. Again, that's basis.
So, in some ways, what geometry then becomes is looking at this classification, at various classifications, and seeing where in the intersectional classifications there exist things and where they don't.
That strikes me as very similar to something like if you have a beak, you have 2 legs. Again, as in biology, there is a similar kind of.
And it looks kind of like this. Those trees.
Looks like a biological.
Yeah.
Maybe in your next video we should talk about that. The connection between. Parallels between this kind of classification. And the theorems which are actually laws. Do that in biology. The biological space of possibilities of possible shape, trait combinations.
That's something.
And the laws governing them.
That
will be a very interesting exercise. This seems fairly simple, but if you're doing some biology,
you get large more complex. Various traits, which will come into play.
And this you prove simply by axioms and definitions. Whereas in biology you prove by observation. That's the only difference. Very interesting. Okay.
Okay.
So
I think
see you again in the next video.